So I haven't done a YouTube clip in a while, but recently I finished a project on light and pressure and how it adapts and how blobfish and anglerfish and bluntnose six-gill shark adapt to withstand these environmental conditions. But I would love to be able to talk about just anglerfish, but I think that being able to compare them all is probably the most interesting part. So I'll talk about what I found, and one of the most interesting parts of the study of fish has been a very simple food retrieval system and simple digestive system. This is because little food available in the midnight zone, and they mainly eat dead matter which has already started to decompose, so therefore requires little enzymes and mechanical digestion to continue its breakdown. Although it's highly unlikely, it's important to consider that pressure and light could possibly not be responsible for the adaptations of deep sea species. So I've been looking at the adaptations such as swim bladder for none of them have a swim bladder, and blobfish have gelatinous skin instead to control the buoyancy. And in terms of light, anglerfish have their own form of bioluminescence in the form of an esco, which is a fishing rod shaped organ. So yeah, although it's therefore the adaptations of species could have been adaptations of less obvious variables within the midnight zone. So I immediately ruled out things like water, salinity, pH, computation, etc. And I did this because at the end of the day there were so many variables to consider. I was trying to look at the main ones I wanted to research. So I also wanted to look at temperature, but I felt that depending on the location, time of year, etc., it's also ever-changing variables. So it was hard to choose not to do that and to take that out of my research. But I think it was necessary, otherwise I would have never been able to gain a conclusion. The evidence that I found, so I had to compare all my species that I chose, the Atlantic cods. This was another species I chose to use as a test to compare to a shallow water fish. Well, I wouldn't say it's particularly shallow, but in comparison to living at pressures in the midnight zone of the ocean, it's what you'd consider as shallow swimming fish. Anyway, the evidence shows that the Atlantic cod was not adapted to live in the depths of the water because, well, it had a swim bladder which prevents it from descending below 600 meters. The Atlantic cod also had a skeletal system made from bones rather than cartilage. So, well, it'll be like brittle bones that sort of just break, wouldn't they, at high pressures. And is streamlined, so it can swim to hunt for prey. I think being streamlined is another sort of difficult thing to explain. I think that if you're streamlined, you're designed to be swimming at higher speeds, for example. And if you're in a deep sea, you don't swim at higher speeds because the energy efficiency sort of exchange wouldn't be in the species' favour. Because let's say you're swimming super fast and you weren't burning many calories because you're in shallow depths, but then suddenly you're in the deep depths of the ocean and you are swimming fast but you're not actually going anywhere. So it's kind of against the idea. It's sort of doesn't work out for you. and also you'll be burning so many calories, so you'll never get your food, and you're burning the calories before you get the calories. So it doesn't work to be streamlined. It's not effective. It sort of just bob around and floats, I think, is sort of what happens in the midnight zone. Yeah, so let me just continue. As it has a greater speed range, it can be adapted better to a large range of situations in its own epipelagic environment. Pronunciation's doing well. Environments such as attracting a mate. Those fish without swim bladder show an adaptation to living in deep sea pressure environment. As mentioned above, the blobfish, anglerfish and six-gill shark all have cartilaginous bones to withstand the pressure, and they have no scales. Scales is another form of ensuring the species is streamlined, and obviously, like I've mentioned, it's not essential for it to be streamlined. They move very slowly. Each studied fish has a dullish colour as a camouflage, so they could blend well with the environment. It'd be dark, so last photon is absorbed into the ocean. It's 1,000 meters, so it would be pitch black pretty much, apart from the forms of bioluminescence that will be floating around the ocean. But that's why they're pretty much dark. It would be a wasted feature if they were like high vis. It's not certain when the six-gill shark was first spotted. However, fossil remains have been identified. Despite the prehistoric origins, it appears to be the least adapted fish studied because it needs to be able to move between zones to survive. It eats on the side of its mouth, which still allows the water to flow through its gills and reduce the drag. So, going back to the first point I mentioned there, from my research, I did find out that actually, I believed that the six-gill shark was the least well adapted to the midnight zone. This is because it could not solely survive in the midnight zone for forms of procreation and to be able to eat and things that a species need to survive. It cannot remain in the midnight zone for this to occur, so it does need to go into shallower areas, hence why it does have oily liver rather than just a swim bladder or just gelatinous skin. And eats on the side of its mouth. I watched a little documentary, and it was showing me that actually when a six-gill shark eats, it doesn't go straight to the food, it goes down the side, so it means it's not going to be stopped in its tracks when it swims, because obviously fish need to continue swimming to allow for oxygen to go to the gills and enter its bloodstream. And also, if it went straight in the mouth, they wouldn't have space down the side of the mouth, so they only use half the mouth, so it still allows for water to flow through. The anglerfish seems to be clearly the most adapted to living in the midnight zone, having the extraordinary adaptation of the esca, which allows for its bioluminescence. This helps attract prey and a parasitic mate, which then allows for procreation to occur. Also has high levels of TMAO, which allow it to adjust the buoyancy so that it can move a little through different zones. Greater depth range than both the blobfish and the six-gill shark, which is impressive. Also, there's another part that I was going to mention, but it was the fact that it has no immune system, which allows for the parasitic mate male anglerfish to be able to attach onto its body without the female seeing it as a foreign invader. I think this is a incredible mutation that would have occurred to allow for this, and has benefited it well. And also because there'll be a high increase, constant overload of bacteria and no immune system, practically nothing, it allows for more mutations. And obviously some mutations are not always beneficial, but due to it being so well adapted, you can assume that there have been more beneficial mutations than negative mutations. The next thing would be that evidence access suggests that the blobfish is the least adapted to the study, as the fish it's not adapted well to getting quantities of food very fast. Perhaps the blobfish is just low evolutionary level, which is hard to assume, but understandable considering it's dying out quite quickly and there's 420 left. And so obviously it's on the endangered species list, but not many people are looking out for it because it has no medical properties that can help benefit humans, and obviously there's not much meat on it, it's just fat. Although all three chosen midnight zone fish cross over the depth at some point, in the midnight zone, the blobfish and the sixgill shark can leave the zone. It can be assumed that this is because the blobfish and sixgill shark are not completely adapted to the midnight zone, and their physiology and behavioural patterns require them to move zones for the change of environment for prey or procreation, which I mentioned earlier. The anglerfish, on the other hand, is unable to move zone. It can also be looked at from another perspective, in that the anglerfish does not require change in environment and is extremely well adapted species or fish, has the perfect tools to survive in the no sunlight and high pressure environment. But also you can see it on the other hand as being the least well adapted, in terms of it hasn't been able to adapt fast enough or well enough to be able to make the most out of being able to go into other depths and being able to survive in the other depths. So it hasn't been able to evolutionarily be able to gain the tools to be able to survive in other environments. I could go through the weaknesses of my research, but considering I didn't go through the initial research collection and facts, I think that wouldn't be an interesting idea. Also, another situation that I'd just like to mention is that science in the deep sea and ocean is a really new thing, and I had really limited research to depend on, and there were limited amount of people that I could try and talk to, and considering I was in the middle of a pandemic, not many people were willing to talk. But I would just like to state that anglerfish will always remain the most interesting fish in my heart. Yeah, thank you.